quiz. I post solution for you. Most of it did very well. So if it's going to be anything special, I can explain it later. You see this is the first one. You want to find this integral. Okay, you want to find this integral from 1 to 4. 1 to 2, just break it into parts and you give us the integral. The one I was talking about, you see this integral in calculus 1. You're not going to write the first one, the second one, the third one. Then you go back to the first one, the second one, the third one, the first one. You just give me 1 page of solutions. You see, this is not the way we do it in calculus 1, unless you copy a machine. So this is how you are going to write it down for us. You see, it's clear that this integral by the power rule is 1, 2, 3. You substitute, get the example, and you get the result right away. Okay, don't waste your time. So just use these methods. Your method is correct. Okay, that's going to be one. And at the end, ln2, just change it. Most of it did. So 9.4 is going to be the final answer. Okay, the second one is 0 to 1. It's a substitution method. Again, most of you did it very well. You take the u will be 8x plus 1, du dx, you substitute. Make sure you change the limit of integrations. And then we change it to the u to the half as substitute. Some of you missed that one, 8 here. But otherwise, it's a 13/6, the final answer. Okay, just check anything, you just let me know. So that's the first one. The second one, substitution method, mostly did very well. Very happy about this type of integrations, because you are going to have something like 4 to 6 questions related to the substitution method. Again, you know that it's a power rule. We take the u to be x to the 5th plus 7. You substitute, simplify, you get u cubed u, and then the substitution be done. The next one is this one. U equal to the x squared. The du will be 2x dx. Okay, and the dx is du over 2x. You substitute, get the result. Some of you try to use another method, but you just didn't understand the method. Okay, I told you that. If you check it, this method, you will see it somewhere else, but you have to explain it. You see, this is the method that you will see if you search on internet, you will see this method. U equal to the e to the x squared. Okay, then you differentiate it. We don't mind, but if you can explain how you get it. Okay, the du for this method is going to be 2x e to the x squared dx. You see this one? Then you have to show that this portion inside, you see this portion inside, x e to the x squared, it's going to be what? You want to find the dx. Dx is, you find the x e to the x squared dx from here. That give you something like 1/2 of the du. Then you go back and substitute. So that integral would be 1/2 of the du, which is going to be u half plus c. Then you substitute. Yes, but the way you did it, you just copy a solution in between. You didn't get how you get this type of ideas. And this u over 2, not u sub 2. You see, that's clear that you copy other solutions. We don't mind. I don't mind. But if you can write it down correctly, even if you copy it, try to copy it correctly. Okay, but easy method to do it. U to be there. This very standard, integral really. So the solution is 1/2 of e to the x squared plus c. The next one is this one. Seems that there is no power here, so we call it u equal to the 5x plus 3, and you just simplify it 1/2, 1/5. Everybody got this one right, which is very good. It will be repeated. This quiz will be totally repeated on the final. Okay, so this is the number 2. Again, there was nothing that I should explain, but although I will remind you again. A little bit more involved was this one. Again, everybody got it right. You have to move this one up. A couple of you made a mistake. You write a -3 here. It's a -1/3. Then inside u substitution method, you get to the u to the negative 1/3, and this is the final answer. Again, we didn't have any difficulty with this. And this problem, I give you the shortcut. Some of you did the full solution. It's very good, you know, and you get a correct answer. But you better use a shortcut. The shortcut was the definition of the average value is 1 over b minus a to b f of x dx. You substitute, you see, you put all this under it. I give you a shortcut. That shortcut can apply only when this coefficient is a constant. Okay, that coefficient was e to the ax dx is going to be e to the ax divided by a. Because when you differentiate, derivative of ax is a. So when you differentiate, multiply by a, when you integrate, divide by a. Just for a, say not for anything else. So this simply, this integral would be, we repeat the exponential function, we divide it by the coefficient here, negative 0.05. And we want it from 40 to 60. You substitute, simplify, and you have to use your calculator. Give us the final answer. Most of it did very, very well. 8.55. I gave this one on the final that I had. We did the same calculus at the university yesterday, and I graded their paper. That was the, you know, the same one. It's a very popular problem. With supply, demand, all this type of problem. Okay, so since it's going to be, you know, takes times, this is a good method to just substitute to get the results. But although, you know, you did substitution method, very good, but it takes times. Okay, so that was the point about number 4. And this one, you just missed some. I don't know why you missed 1/3 here. You see area under a curve when you have only one graph is going to be just from 0 to 1. You integrate it. See, simple integral, and the substitution, the result is going to be 1/3. Some of you missed the second integral over here. You missed the cubed here. That's why you didn't get 8/3. Some will get 36. I don't know how you get 36. You better check it. You better check it to make sure that when it's going to be repeated, you'll be fine. So that is for one curve. But if you have two curves, you have to, you know, that you have to put them together to find the point of intersection. Okay. The point of intersection, again, be careful with this equation. Some of you missed the equation here. Okay. You have to move everything to one side of the equation and factor it. You cannot move the 6 to the other side as you did, a couple of you. So it's going to be between -2 and 3. Then we test to see which curve is going to be on the top. Okay, if you put x equal to 0, the line would be on the top. So we integrate it. And integration and the substitution, the answer is 39/2. A couple of get 125, I think, over 6. I didn't get time to check how you know, where did you make a mistake. So just check it. Check, make sure that no. This is 39/2. I know. I checked mine a couple of times. So this must be a correct answer. So check. And again, this answer must be positive. So if you get a negative answer, probably that top and the bottom one, you have to switch it, or you double check it, because this must be a positive answer. Okay, any question? And there was these two VIPs that most of you did very well on this one. Again, this type, u would be 1 plus e to the x. Okay, this is the one, and the du and the dx would be du over e to the x. And you go back and simplify it. Okay, and then you get to the, you must get to the u to the 1/2, which is going to be u to the 3/2 over 3/2 plus c, and the final answer. Again, almost everybody got this one right, which is very good. And finally, this famous problem, ln x to the 5th over 5, it's a power function, u will be ln x. Again, nicely, you have to give us, what is it? Some of you didn't say, didn't take any u, didn't take any du, but you write, you know, u to the 5th over 5 or x. You have to give us the substitution, you see. U and the differential of the u is part of the deal for all of them. So that would be the final answer. Okay, and almost, you know, everybody got a good one, which is a very good sign. Or so repeat it again, go back, and I post this one just tonight. And just if you missed a couple of points, just correct it. 6 out of 15 you already got. We need 9 more questions. Okay, any question? So let's see what we need to know. We have to, mostly this test is going to be mostly test 3 really and quiz 4. So we need something like a couple of problem from the first part. Okay, we just go over those to just make sure you remember it. So this is going to be the first topic. The first topic, of course, is that one-sided limit that we start with. Okay, so we give you one again on this one. So that would be final review question number 1. Okay, final review. So we go with the problem number 1 or the topic number 1. A function is given to you is a piecewise defined function, and you want to check the right and the left limits. Again, it's not a difficult problem, but you've got to be careful when you write the limits. It's going to be x less than 2, and we have the x squared minus x when x is greater than or equal to 2. Okay, it's partitioned around the 2, so they ask for right left limit. So we did it carefully because they may switch it. So the first part that they ask for the, okay, they ask for the limit of f of x, and this is x goes to 2 positive. You know that the 2 positive means x is greater than 2. So you have to use the second part. So this is going to be, you bring the function, okay, and then you substitute. So that gives you 2 squared minus 2, which is 4 minus 2, which is equal to 2. Okay, so this is going to be, so read it carefully. They may switch it. They may give you x to -1 first, okay? -2 first. Second part, they ask for the limit of f of x. X goes to 2 negative. 2 negative means x is less than 2, so the function to be used is the first part. So that gives it the limit of the 2x minus e to the x minus 2. Okay, x goes to 2 negative. And then you substitute, so that give it 2 times 2 minus e to the 2 minus 2. 2 times 2, 4 minus e to the 0. Everything to the 0 is 1. So that gives you 4 minus 1, which is equal to 3. Okay, so the right and the left limits are different. So the limit does not exist. That would be the part 3 they usually ask. So you to explain that the limit of f of x when x goes to 2 negative is not equal to the limit of f of x, x goes to 2 positive. If they are the same, you say, oh, they are the same. So that would implies that the limit of the function when x goes to 2 does not exist. Okay, if they are the same, you say, oh, the limit of f of x, x goes to 2 is equal to the same number that's given to you. Okay, question? And the part D, they usually ask for the exact value, f of 2. F of 2, you go back to see where you can put x equal to 2. You cannot do it for the first one, but you can do it for the second one. If the second equality is also missing, in that case, f of 2 is undefined or does not exist. In this case, it does. So you substitute, so that gives you 2 squared minus 2, which is going to be 4 minus 2, which is equal to 2, and you're done. That's it. That's the first topic. Any question? So 2 other possibility is that this may be equal to, so that would be equal to the limits, and this may be missing. I mean, the equality would be missing. So in that case, you miss the f of 2. So the f of 2 is going to be undefined. Okay, that's topic number 1. Topic number 2 is special limits. Remember, this is the limits that we did at the beginning. Okay, special limits means we try to find the limits, we get to the 0, 0. 0, 0 means, you know, they would have a common factor. Remember, you have to eliminate the common factor. and then redo it if you like. So there are two possibility, polynomials and the rational function and the radical function. So for the polynomials, you get this one. If you need more to practice of this type, you have to go back and check your first quiz. These are all coming in your first quiz or the first test. X goes to the negative one. Now you substitute to confirm that it's going to be 0, 0, you will see it. Okay, if you substitute, it's going to be 7 times negative 1 squared minus 2 times negative 1 minus 9. And this is going to be negative 1 squared minus 1. Okay, operate on the top. Negative 1 squared would be 1. So that gives you 7 plus 2 minus 9. And this is going to be 1 minus 1. So that would be 0, 0. Okay, so this means the top and the bottom would have a common factor. That common factor is going to be x plus 1. Just, I just remind you, you don't have to write down on the test that x plus 1 is a common factor. That's why we get the 0, 0. So go back, pull out this common factor from the top and the bottom, and simplify it, then substitute to get your limits. So there you are. Limit of x goes to negative 1. Pull out that common factor, you see the common factor on the top, the common factor on the bottom. So the top, what's the leftover? You see, this is 7x squared, this is x. So x times 1 would be 7x squared, x times 7x. Numbers, negative 9. 1 times what would be negative 9? 1 times negative 9, see? And this would be, of course, x minus 1. See, quickly, we can, pull out that extra factor. Now these two would cancel out. So that give a limit of 7x minus 9, x minus 1, x goes to negative 1. Now substitute. It's going to be 7 times a negative 1 minus 9. And this is going to be negative 1 minus 1. So the top would be negative 7, negative 9, negative 16, negative 2. So the final answer would be 8. And you're done. Okay, any question? So just pull out that common factor and simplify it to get the final answer. That's a type 1. The type 2 is going to be a little bit more involved, but we try to give you something short because we know that the time is not going to be much. But we give you one. So that's a limit of radical x plus 1 minus 2 over x minus 3. Okay, and the x goes to 3. The difference is this radical expression that we see on the top. So if you simplify, they put the top, 3 plus 1 would be 4, radical 4 would be 2. So the top would be 2 minus 2. And the bottom one would be 3 minus 2, which is a 0, 0. See? So you have a common factor. What's that common factor? You pull the 3 to the other side, x minus 3. Again, remind yourself, just remind yourself that, oh, the x minus 3 is a common factor. A is going to be a common. Okay, this is going to be a common factor. Now, how are we going to take care of it? You already got it here. Remember, you multiply the top and the bottom by the conjugate of the radical expressions, means radical x plus 1 plus 2. Okay, multiply the top and the bottom to get this number. So we start it over. It's a limit of x goes to 3. That's it. The top and the bottom by radical x plus 1 plus 2. So we already got radical x plus 1 minus 2. So we multiply by the conjugate. So radical x plus 1 plus 2. Okay, same thing here. This is x minus 3. You times it by radical x plus 1 plus 2. Okay, now the top, we just use the algebra. That's a special product. It's going to be a square of the first times a square of a second. We'll just multiply these two together. Radical would disappear. That gives you x plus 1. Okay, and -2 times 2 would be -4. Remember, a square minus b square. The bottom one, you keep it as is. Don't change it, because this should be, help you to simplify it. Now the top x plus 1 minus 4 would be x minus 3. That's how you get that common factor on the top. So limit of x goes to 3. You see the top would be x minus 3. And the bottom one would be x minus 3 times it by radical. X plus 1. Okay, plus 2. That's it. Now we have the common factor. You must get that common factor. Otherwise, you may miss the sign here. Some people, they miss this is 2 times 2 would be 4. Some of you write it down here. Write it 1, write it 2, so they won't get the common factor. So it must get, and there is going to be a 1 on the top. Okay, so this is going to be the limit of 1 on the top, and this is the radical x plus 1 plus 2 when x goes to 3. Now, if you substitute, so that give you 1. You substitute 3 here, so that we have 3 plus 1, which is a radical 4, plus 2. 2 plus 2 would be a quarter. So, I think you just got it in your maybe quiz 1. Same problem. So that would be the second topic that we are going to have. Any question? So just, get a couple of them from that, the quiz 1 or the test 1, both of them. Just practice, make sure you have no difficulty, and you should be able to do it quickly. Some of the problems are straightforward, just do it quickly and then go back. Or just a couple of them, it takes a little bit more time. Otherwise, it's going to be short, because we know that it's 15 problems in 2 hours. It takes time, but it can be done. How did it go to x minus 3 on the top? We just simplified, see, x plus 1 minus 4. 1 minus 4 would be -3. So that give you the 1. Okay, any question? So that's your, did I get the 4 by -2 times 2? No, you see, x goes to 3. X goes to 3. Oh yes, this is it, 2. Yeah, that's it. Yes, it's a, yes, it's identity, a special identity. Radical x plus 1 times radical x plus 1, we get x plus 1. -2 times 2, -4. Okay, a special, we call it a special product in algebra. Okay, so that is topic number 2. So this is, we are out of test 1. Now we go to the whatever we have from test 2. Of course, chain rule. Okay, chain rule, differentiating these functions. We give you a couple of them. You're going to have 2 types of differentiation. One of them is going to be just the ordinary one. Okay, so it's topic number 3. We are going to use the chain rule. For this, you just need this formula, remember? Derivative of u to the n is going to be n u to the n minus 1 times u prime. That is going to be your formula for the chain rule. And we have kind of 2 types of problems. One is just the power function, and the other one you may get it with the product. Okay, so these are again from the previous review, the same question. So f of x equal to the first one, f of x equal to the x cubed. Okay, x cubed plus 4 e to the x, everything to the 6. You see, you are going to call the inside u. So you may think about this one as u to the 6. And you can remind yourself that what's going to be the formula. So u to the 6 prime is power down 6 u to the 5th times u prime. That's your formula. Just copy the formula. Okay, so what's going to be f prime of x is equal to 6 down, the power down, 6 x cubed plus 4 e to the x to the fifth. Now u prime, derivative of the inside. Inside, derivative of the x cubed would be 3x squared. 4 is a number. And derivative of e to the x is just e to the x. So it's going to be times that by u prime, 3x squared plus 4 e to the x. And with that, the only simplification is going to be monomials. If you see single terms around, okay, isolated, you put them together, but there is no single term here. So that would be the end of the problem, and you don't have to do anything. Okay, any question? That's a type 1, just a u function. The type 2 for this group is a product function. Okay, g of x. G of x equal to the x squared. Okay, x squared, the fifth root. The fifth root of what? 4x to the fifth plus x squared. That's the option. Okay, the first thing to do is to change the radical. So we change the radical by x. Okay, so we're going to have what? We're going to have the g of x equal to the x squared times it by 4x to the fifth plus x squared to 1/5. Now you have a product of two functions. So you apply the product rule. Derivative of the first times second plus derivative of the second times first. Derivative of the first is easy, 2x. But second times first is u function. Okay, it's u to a fifth. So you have to apply the chain. So it's a multiplication and the chain. Okay, so and that's it. It's going to be g prime of x equal to derivative of the first function. Derivative of the first function is simply the 2x times it by the second, 4x to the fifth plus x squared to 1/5. So that's a step 1 plus second first. Second is u to a fifth. So we have to apply the chain rule. This means 1 down, a fifth, 4x to the fifth plus x squared to the 1/5 minus 1. It's going to be negative 4/5 times u prime. Then times it by the first. So we take this one first. It's going to be plus 1/5, 4x to the fifth plus x squared to the negative 4/5 times it by the u prime. U prime derivative of the inside, which is 20x cubed plus 2x. See, that's the derivative of the second one. A fifth done, if 1/5 minus 1, which is a negative 4/5 times the u prime, but we are not done, multiply by the first one, multiply by x squared, because this is the product rule. Okay, but a monomial here, you see this monomial? So we put these two together because you have to put these monomials together. This is 20x to the fourth, of course. Okay, 5 times 4, 20, 20x to the fourth. So the final answer would be g prime of x equal to the 2x times, I just repeat it, 4x to the fifth plus x squared to a fifth, and then it's going to be a fifth, 4x to the fifth, we just repeat this one. Oh, I'm sorry, this is 1/5 of the x squared. I have to put them together. And this is going to be negative 4/5 times it by 20x to the fourth plus 2x as the final answer. Okay, so the extra job is going to be just a product of two functions. Okay, so this is going to be the fourth. Yes, you are right. Any question? So that's type 2. Yes.
Was it, I don't remember what questions, we were not allowed to leave the exponent as a negative number. So for my,
Integration.
oh, okay, integration. Okay, so it's fine for like the,
Yeah, it's fine.
oh, okay, because I did like the 1 over, like instead of leaving the negative 4/5, I put it as a 1 over that,
Yeah.
like, take away the negative. So would that be okay? Because I get confused
Yeah,
as to
yeah.
the negative. Oh, okay.
Yeah, even you can go on, some people go on, change it to the radical again.
Oh, okay. Yeah, just making sure.
It's fine. This is what I want.
Yeah. Okay.
But
Thank you.
in the case of integration, because we do something else most of the time with the integral. Remember, sometimes we evaluate it, some it's average, etc. That's why we want to get the habit of changing it.
Okay.
Okay, but it's not a big deal. But this is the way we did it, so we just continue. But anything extra you do, this is up to you. But I'll be fine with it. I like these two to be put together. Okay. This 1/5 of x squared. When you cannot simplify it, even if you leave it, that would be fine. But if it's going to be 2x squared, for example, you better put it up in front. This is all we need. Okay. Any question? So this is only two cases we have. We may be given the quotient, and then it's up to you. Okay, the quotient is 3x squared plus 7e to the x, okay, and that's 8x plus 1 to the 4. Then since we get the habit of, in the case of integration, and there is a power, move it up, so we do the same thing over here, and we avoid the quotient rule. But if you like it, you can use the quotient rule. But basically, again, if we move it up, so it's going to be 3x squared plus 7e to the x times it by 8x plus 1 to the negative 4. You see? We change it to the product and we just apply the product so that we memorize. Okay, one standard method. But if you want to do the quotient, you have to do the quotient rule and simplify it. Okay, so it's same thing, derivative of the first times second, second first. The first one is straightforward, but the second one, you have to apply the u to the negative 4. Okay, so this is it, h prime. Equal to the first one, derivative of inside 6x plus 7 times e to the x, because e to the x won't change. So 6x plus 7 e to the x times it by the second one. Done. Second verse is u to the negative 4. You see, remind yourself that u to the negative 4 prime, power down, negative 4, u to the negative 5, and the u prime. This is the formula that you have to apply for the second part. So we repeat it, it's a negative 4, 8x plus 1 to the negative 5 times u prime. U prime of inside would be 8 only. But times it by the first one, 3x squared plus 7e to the x. Okay, but you get these two monomials, coefficients. You have to multiply them together, that gives 4 times 8, 32. So the final answer would be this one. H prime of x equal to the 6x plus 7e to the x times it by 8x plus 1 to the negative 4. 4 times 8, 32. So minus 32 times 8x plus 1 to the negative 5, and the 3x squared plus 7e to the x as the final answer. Okay, so when it's a quotient function, this is a suggestion that you move it up and change it to the product, and then apply the product one. Any question? So we have one more with the radical. I do that one too for you guys. Okay, just make sure to get that radical one right. This is very similar to the previous one, but the extra one is this. So you know that this is the one that you are going to change it. You change the radical into the x squared plus 6 to the half. Again, you better move it up, make it very easy derivative, to take. So the suggestion is going to be, that's a kx, it's going to be 2x times 2x x squared plus 6, you see, to the negative half. See, now it's very easy integral. Sorry, easy derivative. to take. Derivative of the first times second, just 2. Second first is like u to the negative 2. So it's going to be k prime of x. Derivative of the first one, 2 times second, x squared plus 6 to the half. Now u to the negative half down. Okay, x squared plus 6 to the negative half minus 1 is like negative 1 minus 2, which is a negative 3 half. U prime inside 2x, and you have to times it by the first one. It's coincidence that you get a 2x again. Okay, so I take the derivative of a second times first. Now again, these monomials, we have to take care of it. 1, 2, 3. You can simplify the 2.5 here. So you end up with the x times 2x, which is going to be 2x squared. So the final answer is this one. Prime of x is going to be equal to what? It's equal to the 2 times x squared plus 6 to the negative half. And here minus, okay, minus 2x squared. 2x squared times x squared plus 6 to the negative 3 half as the final answer. Okay, so these are all, old chain rule method. Just ask you 1 or 2 of these as one question. So that's the type 1 of the differentiation that we're going to have. We're going to have one more, and that would be related to the exponential function and ln function. 2 famous one. We did quite a lot of these type of problems, so we repeat it again. So give you the idea of the formula that we need to use for this one. So for the second part of the derivative question is going to be this one, and this is what you need. You need to know that the derivative of e to the x is just e to the x. Okay, but if you have e to the u, anything other than the x, even a negative x, so that would be what? That would be, we repeat the function, e function would be e function, but we have to multiply by u prime. So it's going to be e to the u, but times it by u prime. That's a chain rule type for the exponential function. For the ln function, the derivative of ln x is going to be 1 over x. But if it's going to be ln of something else, ln u, so it's going to be u prime u. Okay, easy formula, but make sure you know it to get this one through. And very standard one that we have, and we did it before. Part 1 is just a power of the x times ln. We did this one. See, that's one. Is a product of 2 functions. The first function is x to the 4th. The second function is ln x. So it's going to be the derivative of the first times second plus the derivative of a second times first. Okay. So the y prime is equal to the 4x cubed times ln x plus derivative of the, okay, get the derivative of a second times first. So the derivative of a second one, ln x, is 1 over x times it by the first one, which is x to the 4th. But you know that you have to simplify this one. You simplify that, give you x cubed. So the y prime is simply 4x cubed ln x, okay, plus x cubed, and you're done. You can't do anything else. Don't factor it, or try to combine them. Nothing is impossible or possible. So this would be the end of the problem, and you have to simplify this. Okay, question? So that's a type 1 of these problems. The type 2 is the chain rule type. It's a famous one that we did it before, but some of you missed it on the, I think it's test 2 maybe, or test 3, 2. X to the 4th, 6x squared plus 1. So you have to take this one as ln of u. You may think about it as ln of u. And now you know that derivative of ln of u, ln u would be u prime u. Just copy this formula. Okay, so g prime of x is simply u prime. That's going to be 4x cubed plus 12x divided by x to the 4th, 6x squared plus 1. And it's done. You cannot do anything about it. You cannot simplify it if you factor it. So what's the use? So that is it. You know, it's just the derivative of the function u prime u. Okay, any question? So this is regarding the ln function, and for the exponential one, the best one is just a product of the, you know, the power of the x, and we already done several problems on this one, and even the one that we are going to talk about it is going to be given. We did this one before, so we may create something else and ask you to do it. So that's a y equal to 4x cubed. Okay, 4x cubed e to the negative x squared. Again, it's a product of two functions. One part is exponential function, and the other part is just a polynomial type. So the y prime is going to be derivative of the first one, 12x squared. Okay, times it by the second one, plus second first. The second one is just exponential function. Exponential function never change. Times it by the u prime, which is going to be negative 2x. Now this is times by the first one. See, that's going to be the one. But you have to simplify these monomials, you know that. So the y prime is going to be equal to the 12x squared e to the negative x squared. Now that gives minus 8 x to the 4 e to the negative x squared. I think that was exactly one of the questions that you take on maybe test 2. So if you just check the test 2, if you like, to get the to get more of these type of problem. This is the one that you have to simplify. Okay, so that's going to be part C. Part D is just to remind you that some of the property of the log that we use is very similar to the part B. Is the ln of the cube root. Cube root of a 6x cubed plus x plus 1. You can do it, you know that if you want to do it, you have to change the radical first. We always change the radical. So change the radical again here, but you can use an extra property of the ln to simplify it a little bit more. Okay, so that's the idea. So the y is equal to the ln of, it's a 6x cubed plus x plus 1 to the third. You can do the ln u now, but you know that in the case of the log, you can move the power down. That's a property of the log function. So that would be 1/3 ln of 6x cubed plus x plus 1. You see, now you simplify it. So far, it's all algebra, no calculus. Because, you know, you switch the radical into the rational power. And since it's the ln function, any power you can move it down. So now we can differentiate it. Is ln u. So the derivative would be u prime u. So y prime is going to be equal to, okay, a third u prime u. U prime, that give you 18x squared plus 1, and the u, 6x cubed plus x plus 1. Okay, again, you know, you can multiply 3 if you like, or you can keep it. So the y prime is going to be equal to 18x squared plus 1. You can multiply it if you like. It's going to be 18x cubed plus 3x plus 3. The final answer. Okay, that was just an extra condition for, you know, for that function. Thank you. That. Any question? So these are, you know, the one that we did before, basically in test 1 and test 2. So this is going to be something like 4 or 5 questions so far to get those preliminaries. Then that will take us to the mostly test 3, first derivative test, the second derivative test, okay. finding a maximum, minimum, and those type of problems that we did. And we did all of them before, really. So I just quickly, let's see, and just remind you something that's going to be a little bit different, okay? So that's number 4. You have the solution of all of them. If you check your test 3, you will see all of them. I just repeat them again to get these numbers. Okay, what's the question? Does X always turn into 1? What do you mean?
Sorry, so when you find the derivative of X, like in 6X cubed plus X, so that X always turn into a 1.
Yes, derivative of X is 1.
Okay.
Yeah, because you bring the power down. Okay, the power is 1. 1 down would be X to the 0. X to the 0 is 1.
Okay.
The derivative of
Thank you.
2X is 2. The derivative of 5X is 5. So the derivative of X would be 1.
Okay, thank you.
Okay. So number 5, the first derivative test. Okay, this is the one. They give me 1 because you know that this is a popular problem. So number 5, 1 question on first derivative test. Okay, you have 2, a polynomial type and the exponential one. Exponential one is the one that we did before, so you have to check it yourself. So I just remind you one of them, you know, that I do the polynomial type, okay, and just check, make sure that you are ready for it. So 1 question on the first. How we find out? They are going to ask you, find the interval where the function is going to be increasing, decreasing. As soon as you see this expression, this is first derivative test. We need a chart for the f prime to find out, okay? So just to remind you quickly, f of x equal to the x cubed minus 6x squared. I'm sure that we did this one before. 9x plus 1. So these problems start with the domain. In this case, is a negative infinity and positive infinity. So we have to check the f prime. So f prime of x would be 3x squared minus 12x plus 9. Double check the derivative. You should don't miss anything here. Okay, we let it be equal to the 0. We have to solve this equation. We factor out the 3. So that gives x squared minus 4x plus 3 equal to the 0. Factor it. So 2 numbers with the product of the 3 and the sum of 4. So x minus 3, x minus 1. Okay, 3 is never 0. So you let these 2 equal to the 0. So that gives x equal to 3 and x equal to 1. So we have 2 critical numbers. Okay, critical numbers going to be 1 and 3. Okay, you have to drop it back into the function and then test it. So we find f of 1. So that gives 1 minus 6 plus 9 plus 1. Okay, that's going to be 10, 11, 6 out of 11, which is 5. So that's f of 1. Then we check f of 3. F of 3 would be 3 cubed minus 6 times the 3 squared plus 9 times 3 plus 1. We check this one. 3 cubed would be 27. 9, 3 squared 9, 9 times 6, 54. Okay, and 27 and 1. 27, 27, 54, and 54. Everything would cancel out. We get 1. Okay, so we have f of 1 equal to 5 to test, and f of 3 equal to 1. Okay, and now we have to test it. You already got the test, you know. You have to do the first derivative test for this one. Okay, so the test is going to be first derivative test because that is the only test that give you where the function is going to be increasing or decreasing. Otherwise, second derivative test can be used also, but not for this one, remember. So this is going to be your x from negative infinity to positive infinity. Okay, the critical values critical numbers are going to be 1 and 3, so going to be 1, and this is going to be 3, and the f prime, this is going to be f prime. Okay, we got the f prime. F prime is going to be 0 in 2 places, and f of 1 is equal to, okay, f of 1 is equal to 5, and f of 3 is equal to 1. Okay, that's going to be the 1. Then you can, this is a polynomial, is quadratic. Between the zeros, you know that the sign is going to be opposite sign of the x squared, which is going to be negative, or you can test some numbers. And you already got this one. You see 5 goes to 1, it's done. So this is going to be up, and this is going to be up. Okay, or you can find the infinity as well, really. This is the negative infinity for the polynomials. You know that. We check it into the leading term. So negative to the third would be negative. You see, this is going to be negative infinity. And this would be a positive infinity. Okay, so that's it. This is going to be a minimum. And this is, sorry, that's going to be a maximum. And this is going to be a minimum. So the graph would be something like this one. Even we can graph it, we don't ask you to graph this. It's not difficult. You just put it on the XY coordinates, and then you graph it. So if you give us this chart, we are happy, because f of 1 equal to the 5 is a relative maximum. F of 3 equal to the 1 is a relative minimum. The function is increasing between negative infinity and 1, and 3 and positive infinity, and it's going to be decreasing between 1 and 3. So, the chart gives us everything we need. That is going to be the first one. Any question? The second one, I did it before, so just check it. It's an interesting problem. And you did have it in one of your tests. That is going to be the one. Okay, with the domain of negative infinity and positive infinity. If you check your test 2, probably you will see it. You get only one critical number, and eventually we get a minimum for this one. So that is the first derivative test to get these numbers. Then we have the second derivative test. So we give one question on the second derivative test. You know that for the second derivative, you have to drop the critical values in the second derivative. And if the second derivative is going to be positive, your graph would be curving up, you get the minimum. If it's going to be negative, your graph would be curving down, we get the maximum, okay? So we have 2 here, a polynomial type and the ln one. I'm going to do the ln function for you. So you know that we give you one of those. We give one exponential, one ln during that, during that test. So we may give you about, the first derivative test, second derivative test, or somewhere else. So just make sure you are prepared, and be prepared to apply your calculator. And maybe we did it before. So that's a second derivative test. Second derivative test. So I'm going to do the 6b for you, because the first one is just a polynomial and we did it before. So we check this one, x squared ln x. Okay, you have to start with the domain. This is ln function, domain of the ln, positive numbers only. So get the domain first, positive numbers. Then we have to differentiate it. It's a product of 2 functions. So derivative of the first times second, second first. Derivative of the first one would be 2x times ln x plus derivative of the second times first. Derivative of the ln x is 1 over x times it by the first, and simplify. This would give you x. So we are going to have f prime of x equal to the 2x ln x. Okay, 2x ln x plus x. So that would be your f prime. Okay, now we have to let it equal to the 0 to find out what's going to be critical value. So f prime of x equal to the 0. So that would be 2x ln x plus x0. You have to solve this equation. There is a common factor, x. So we take care of that one first, and we try to get the complete solutions. So if you factor out the x, the leftover is going to be 2 ln x plus 1 equal to the 0. So you have one solution would be x equal to the 0. Never, because the domain, and you know that ln of 0 does not exist. So we have to take care of the second part, 2 ln x plus 1 equal to the 0. Then you have to isolate the ln to solve it. So that gives you 2 ln x equal to the -1. So ln x would be -half. And the x, you see the base is e. So we change it to the e form. So x is equal to the e to the -half. And you better find it with your calculator, because you can stay with this one. If you want to stay with this one, you have to change it into 1/radical e. But since you want to drop it into the second derivative, you better use the calculator to find it. Okay, so it's going to be e to the, okay, e to the -1/2. Okay, 1/2. So let's see. It's equal to, okay, it's almost 0.661. So I'm going to call it 0.61. So x would be 0.61. Okay, so that gives us the critical number. 0.61. You have to go back, drop it into the function first, then you test it. A test, of course, must be second derivative test, because it's going to be given to you. So we go back and we find f of 0.61 into the function is going to be 0.61 squared times ln of 0.61. Okay, you have to get these numbers. So let's do it. It's going to be 0.61 times 0.61, we square it. Then we are going to times it by the ln of, okay, times ln of 0.61. Sorry, I missed it. So this is going to be, so I'm going to times this one by ln of 0.61. Okay, so that gives us a negative number. So I have a negative 0.183, let's call it 1.83. Double check it, to make sure you get the same answer. Okay, that's one. So what do you have? This is going to be, explain how we got the, which one? E to the -1/2?
Yes,
We just solved this equation, ln x equal to -1/2. So in order to find the x, you switch it to the exponential. X equal to the base. Base of the ln is e. So e to the -1/2. Anytime you have the ln function, you want to switch it to the exponential, this is the way we do it. X equal to whatever base is this definition of the ln function. X equal to the e to the -1/2 to get these numbers. Okay, so now we have the candidates, but we haven't checked it. Okay, so we have f of 0.61 is equal to the -0.183. Now we have to check the test. You've been asked to use the second derivative test. So we have to follow second derivative test. So we have to find the second derivative. This is the first derivative, okay? This is 2x ln x plus x is the first derivative. You have to find the second derivative and drop 0.61 in it to find out whether that second derivative is possible again, okay? So find the second derivative. You have to apply product rule again. You have the first times second, second first. You have the first one would be 2 times the second one ln x plus. You have a second times first, so ln x is 1 over x times the first, which is a 2x. Then you have an extra x here, the derivative of x is 1. So these two would simplify, so that gives us 2 ln x, 2 ln x plus 2 plus 1. Okay, so it's going to be 2 ln x plus 3, which is a positive number. I'm sorry, this is f double prime of x so far. Okay, any question? We're just differentiating. And this is the product rule. You have to apply the product rule. You have to have the first times second, second first, 2 times ln x. You have to have a second one, 1 over x, and then 2 and the 1 would be 3. Now you have to drop this 0.61. So it's going to be 2 times ln of 0.61, then plus 3. You have to find this number to find out whether this number is going to be positive or negative. Okay, so we start with the ln of 0.61. Okay, so that gives you negative 49, and then you multiply it by 2. So that gives you negative 9.8, and I add the 3. It's going to be a positive number. Okay, so it's going to be something like 2.2 or 2.01. Okay, so this is positive. Positive means it's curving up. So we get a minimum. Okay, so f of 0.61 equal to the negative 0.183 is going to be a relative, is an absolute minimum, in fact, because this is only limit to minimum you have. But you can, they ask for the max and the mean, so we can say that this is a relative minimum for the, for the function. So that would be second derivative test. I give a short break, we come back and we continue. We have one more concept on the derivative. This is finding the absolute max, absolute mean on a closed interval. Very easy question. And you have it on test 3. You find the critical values, the value of the function at the endpoints of the interval. That give a max and the mean, then the rest is going to be the integration that we did it. So we do as much as we just repeat it again, because those problems are exactly the same. Okay, see you in 10 minutes. Okay, so we are going to continue. So that was question number 6. Question number 7 is just absolute max, absolute mean on a closed interval. Okay, it's easy question. You just find the critical values and just check it with the interval. Okay, I just remind you one of them. Again, that was on test 3 again. Okay, and that's a 7. Okay, this is going to be absolute extrema on closed interval. Okay, on closed intervals. So no test is needed. That was the kind of optimization problem that we did. Okay, so no test is needed for these functions. Just check one of them. It's going to be mostly polynomial type, and this is the one that we did before. F of x equal to x to the 4th minus 2x squared plus 3. And this is going to be, let's say, on the interval of, I give you the second interval, 2 and 3. Okay, so for this problem, you start with the domain. The domain of this is going to be the given interval. And that's very crucial to make sure that you stay in this domain. So we have to find the critical values. We differentiate. So that gives you 4x cubed minus 4x. Okay, you let it equal to the 0. Carefully factor out the 4x. That gives you x squared minus 1 equal to the 0. Then you are going to have 3 solutions. Okay, for x equal to the 0, that gives you x equal to the 0, 1 solution, and then x squared minus 1 equal to the 0, and that gives you x equal to the positive negative 1. So far, the critical numbers are going to be -1, 0, and 1. Then you have to check, compare it with this domain. You see the domain is, you check. You compare it with the given domain. The domain is 2 and 3. And your critical numbers are going to be -1, 0, and 1. Okay. Then you are going to accept only the one that's going to be inside the domain. This domain is 2 and 3, so they are all outside. Okay, so you're not going to use any of those numbers. So you have to only 2 and 3. So you get a chart. Okay, this is going to be your x, and this is going to be your f of x, the function. F of x, which is x to the 4th minus 2x squared plus 3. You're going to bring any leftover here. You don't have any, and the 2 and the 3. So in this case, it's going to be only 2 and 3. Okay, so don't be surprised. Probably sometimes we just drop 1 or 2 of these, but this is a special problem that you just wanted to know. Okay, just evaluate and just compare them together. 2 to the 4th minus 2 squared plus 3. So that gives us a 16 minus 8 plus 3, which is 11. Okay, and we have the 3 to the 4th minus 2 times 3 squared plus 3. 3 to the 4th would be 81. Okay, 3 squared would be 9. And that gives us 18 plus 3. So we just check this one. This is going to be, okay, the function is 2x squared. Yes, what's the question? To get these numbers and compare them together. Why did I drop the critical numbers? You see, because your domain is, so you compare your domain. Domain of this function is 2 and 3. The critical numbers must be inside the domain. So you have a -1, 0, and 1, and they are not between 2 and 3. because this is your function is defined on this interval. Okay, so in this problem they give you two intervals, the first one and the second one. I just did the second interval so that you know that with the difference. Okay, so this is going to be what? It's 81 minus 15, and this is going to be 66. I think that's what. Okay, now we just compare these two numbers together. We compare to these numbers together, so the minimum value of the function is going to be 11, and the maximum value of the function is going to be 66. No test is needed for these numbers. Okay, so just compare to make sure that they are going to be the one. We compare what? We apply the given point to 6. I don't understand what is your question. This is the, the critical numbers. You have an interval. So you have to consider your interval over here. Then you just substitute the numbers. Okay, so that's going to be the case. Any question? This problem would have two parts. Let me explain the first part too so that you understand it. Make sure you have no difficulty. You see, that's a part A. If they consider the other interval that it's given to, we give you, of course, one interval only. You see, this problem would have the second part. You see, that's the other part of the problem. In this part, everything is the same. So you just consider the critical numbers. You see the critical numbers. The critical numbers was -1, 0, and 1. Now, if you check, you see between -3 and 5. -1 is in, 0 is in, and 1 is in. So for this problem, you have to consider all of them, you see. It's going to be your x, and this is your f of x, x to the 4 minus 2x squared plus 3. You have to evaluate it at the -1, 0, 1, -3, and 5. Then compare them together. Because all of them are inside the interval for this interval. So it depends on the given interval. You see this interval, all of them are out. So we didn't consider it. So I just leave them this one for you to do. It's not difficult. So find these numbers, compare them together. So the max and the mean would be different if you pick different intervals. Okay. So for this type of problems, remember no test is needed because it's already determined. Because after this, you see, in the other problems that we did, if you remember the polynomials, the domain was -∞ and +∞. That's why you tested, but domain here is a -3 and 5, so it's very restricted. So make sure that you don't bring anything extra. Okay, that is the differentiation, all we have. We get to the integrations. These are the one that we did, mostly 6, on the quiz that you have. Okay, different type of integrations. So what I'm going to do, I'm going to do the integration by parts is the new one that we haven't done it. And a couple of application problems that we have over here. Okay, so this is it. I do number 12, 13, and 14 to make sure that we get these new parts. Number 11 is the average value, is the one that you did on your quiz. Okay, so and number 12 is just the area between two curves. Probably did this one before, so just quickly remind you. But let's do number 13 first. You didn't do this type of problems. And we give you one. It's kind of application problems, okay? The marginal profit function is given to you if we give you something with a P prime. So it can be a profit, it can be cost, C prime. Okay, it can be revenue, R prime, or it can be supply. Okay, supply demand, S prime. So these are a very popular problem. So what we have is marginal profit is given to us, P prime of X, which is equal to the 100. Okay, 100 minus 0.02x. This is given to you with one initial condition. The initial condition that the P of 0 is equal to the 0. Okay, so that's a marginal profit function. And they ask you to find the profit function P and the profit on 10 units of the production. This is profit of the X and number of the unit of production. Okay, so when you find it, they ask you to find P of, okay, P of 10. You see, that's going to be the case that we have. So anytime you see P prime, F prime, G prime in calculus, and you want to find the function, you have to integrate. So we integrate to get the P of X. So P of X is going to be integral from 100 minus 0.02x dx. And this is going to be indefinite integral. You are going to have a component plus the constant C. So this would be what? This would be, you integrated that, give 100x. 100x minus 0.02 is a number. Then x squared over 2. Okay, plus the constant C, because it's a definite integral. So we simplify these two. So the P of X is going to be equal to the 100x. Okay, minus, you simplify these two. So that give minus 0.01, 01x squared, plus the constant C. Okay, so it's going to be a profit function. But you'll be given that P of 0 is 0. So we're going to use this fact that the P of 0 is equal to the 0. Means you go back, replace the X by 0 to get the C. So in this case, if you put it by 0, so that gives you 0, 0. So that gives you 0 plus C equal to the 0. So C would be 0. Depends on, the given information. So now we have the profit function. 100x minus 0.01x squared. You said it's going to be a profit function, then they ask you to do something about it. What do you want to do? You want to find P of 10. So replace the X by 10. So P of 10 is going to be equal to the 100 times 10 minus 0.01 times 10 squared. Okay, so the first one would be 1000, and this is going to be 100 times 0.01 would be 1. Okay, would be 1, so that gives you 999. So that's going to be $999. So that's, that's an easy problem for just you have an extra condition, you just substitute to get the, okay, to get your result. Okay, any question? So it's a kind of application of the indefinite integral for this, just checking the case that you have in your discipline. So that's the idea of the number 13. Number 14 is new, integration by parts. Okay, we are going to focus with only 2 functions that you have it in your own application problem. So 14, we want to integration by part. Integration by parts method. The functions are going to be either ln function and the exponential function. For the exponential function, we give it a shortcut. For the ln function, you just use the actual one. Okay, so the first one is integral of x to the 5th ln of x dx. Remember the formula for the integration by parts is this one. Integral of u dv is uv minus v du. And the idea is we switch the form of the integral to the something else and hope that that something else would be easier to handle rather than the given one, because this is very difficult. Okay, and we don't know anything about it. So we talk about it for this. You have to pick the u and the dv. For these type of problems, we talk about it. You see, we take the u to be ln x. And the reason is it's easy to differentiate ln x rather than integrating. So we take the u to be always ln x. It's a very unique problem, so you're not going to miss it. The leftover, whatever is left over, we call it dv. So the leftover is going to be x to the 5th times dx. So the dv would be x to the 5th dx. Okay, any question? No. The one that you pick the u, you have to find the du. Differentiate. If of ln x is 1 over x, but times it by dx. Okay, that's going to be du. The one that you pick the dv, you integrate. V would be integral of x to the 5th dx, which is always going to be a power function. It's going to be x to the 6 over 6. No constant c, because this is not the solution of the problem. It's just a partial solution. Even if you carry the c, you get the same answer, but we don't usually add the c here. Now we go back and we rewrite the formula. So it's going to be x to the 5th ln x dx, original one, equal to u times v. U ln x, v x to the 6 over 6. So it's going to be x6 over 6 ln x minus integral of v du. V x to the 6 over 6. V du, and this is du. Multiply by the du. 1 over x dx. You see, the advantage is that there is no ln here, so we can easily find the integral. Now we simplify it first. Always this x and these powers would be simplified. So it's going to be equal to the x to the 6 over 6 ln x minus, when you simplify the top, it would be x to the 5th. The extra number is 1 6, so we can pull out the 1 6. So the inside would be integral of x to the 5th dx, which is very easy to find, because it's going to be just simply x to the 6 over 6. Okay, so it's always the case. This x would disappear. Okay, we would reduce its power, and there is going to be a number 1 6 1 4 1 5th. Now we integrate, so that gives us x to the 6 over 6 ln minus 1 6, and this would be x to the 6 over 6 again. Now we add the constant c. So the final answer is going to be x to the 6 over 6 ln x. 6 times 6 would be 36. It's going to be minus x to the 6 36 plus the constant c. So that would give you the final answer. Okay, we can do all the powers easily. That's one. It's a very popular pattern. You see, it's 5th. It's going to be 6 6 6 6 x to the 6 6 squared 36. Always the case. X to the 7 ln x would be x to the 8 over 8 ln x minus x to the 8 over 64 plus c. So but you have to do it, remember. Just give you the hint to get these type of problems. Okay, any question? So that would be, all the powers are going to be nice except ln x. I'll give you ln x too, so that you know it. Any question? You see, let me just give you ln x. It's very special. It's not on the review, but just not bad to find it. You see, this is again one of those integral that you can do it only by integration by parts. You see, you take the u to be ln x, as we did for the other one. The leftover is going to be dv, but the leftover is just a dx, you see. In the previous problem, it was x to the 5th times dx. There is no x to the 5th. There's only 1. So the other end, we differentiate, that give us 1 over x dx. We integrate. You see, v would be integral of a dx, which is x. Because we want to find the function whose derivative is 1. So that give you x. Now, write your formula. So this is going to be integral of ln x dx is equal to u times v. u v x ln x minus v du. v du. v is just a dx and the du is, sorry, v is just x times 1 over x dx. See, this x and x would cancel out. So that gives x ln x minus integral of what? Integral of a dx. Integral of 1, which is x. So that gives x ln x minus x plus c. So that would be integral of ln x dx. Again, very popular case. So that's a type 1. You see, it's usually multiplied by another function, not polynomials. You know, this ln x and the e to the x, this is the only 2 functions that you have. Otherwise, there's going to be lots of, you know, trigonometric functions. Any question? That is the type 1. Type 1 with the ln function. The type 2 is with the exponential function that we give a shortcut. We can use these methods, but it takes times to be able to do it. So we give it we let you use the shortcut for the second part. So that's a part B, and the integral of x squared e to the negative 2x dx. You see, we talk about it. If you want to do it, yourself, the way you are going to do it is you take the u to be x squared, and your dv would be e to the negative 2x dx. This is if you want to do it. The part that you take the u, you differentiate. That gives you 2x dx. The part that you get the dv, you integrate. But if you do this one, you will end up with the x e to the negative 2x. You are not going to get the easy integral to do, so you have to apply the integration by parts again and again and again. So what we do, we summarize all this information in a table. We say that's going to be a table that we let you use it. It's very popular for, you know, you don't take calculus 2. And calculus 2, this is the one. So this operation that this is u, you see this is u, you just start with the u. You put the u here, x squared, and the dv here, e to the negative 2x. The column of the u, you have to differentiate. The column of the dv, you have to integrate. Okay, and this is the one we call it sine. So the sign is positive here. So you continue. It's exactly what you are going to do here. So what we do, we go to the second part. The sign is going to be alternatively positive, negative. So you differentiate that, give it 2x. You integrate. Exponential function when integrated is not going to be changed. It's a negative 2x. But that shortcut that we gave you is divided by u prime. U prime is a negative 2. So that would be the first part. Okay, for this column we differentiate to get a 2x. For this column we integrate. When you integrate, the exponential function would be exponential function, but you divide by u prime, or you divide by this coefficient, which is a negative 2. Then you continue. This is a negative, so we get to the positive. We differentiate again, that gives us a 2. We integrate. When you integrate e function would be e function again, you see that give you e to the negative 2x. But you have to divide by a negative 2. But you got negative 2 already. So negative 2 times negative 2 would be a positive 4. Anytime you integrate the second part, you're just dividing. So we continue again. It's going to be negative. This would be 0. This is where you stop. But this one, again, you integrate that, give you e to the negative 2x. But you have to divide by negative 2. But you already got the negative 4. Negative 2 times negative 4 would be negative 8. Since we get the 0, you stop here. Any question? So your u must be a powers of x, because that gives you x squared to the 3rd, to the 4th, to the 6th. And the leftover is going to be exponential function. So in the first column, you put the powers of the x so that you will end up somewhere. You see, you get to the 0, you stop. That's why you pick this one to be u. Now, then this is the way you're going to pick the solutions, like the u dv that we did before. Okay, because this is u, this is v, uv, 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 and the uv. You see, this is the way you're going to write the final answer. So what's going to be the final answer? Integral of x squared e to the negative 2x dx is equal to, the first uv is when you multiply these two together. You see, that's going to be the 1. So that gives you negative half x squared e to the negative 2x. That's the first one. Minus second one. The second one is this one, 2x times, okay, minus 2x times, I write it down so that you can see. 2x times what? 2x times e to the negative 2x divided by 4. So that gives you this part here. Then plus, okay, then it's going to be plus what? Plus 2 times, is going to be 2 times e to the negative 2x minus 8. And of course, plus the constant c. You have to simplify it. So that gives negative half x squared e to the negative 2x. And over here, these two would simplify. So that gives you again a negative half x e to the negative 2x. And over here, this is a 2 and the 8. So we simplify that, give a negative 4. So it's going to be minus a quarter e to the negative 2x plus the constant c. So that gives you the integral of x squared e to the negative 2x dx. It's very popular integral. To get this number, the one that you use in your field is only with the x e to the negative 2x dx is kind of prediction for your investment. And this is the only reason that you study this integration by parts. So just the first power, if you like. The first power, but it's nice to know it. Especially, that's why we give you this shortcut, because you just one case only. So why not? We get these numbers. Okay, so this is going to be new for the final integration by parts, 1 or 2 questions, because one of them would be with the ln function and the other one would be with the exponential function. And it can be, you know, in the definite integral, and that's going to be the one. You can use, no, you cannot use it for the first part. This can be used only for the, okay, because for the first part, taking the, you see this second column is going to be difficult for the ln x. The reason that you're going to use this one, this is going to be the case. Is the final 33%? It's 150 points out of 450, which is somehow it's going to be 30% of your, or 33%. Yes, it's 150. And the total possible points is 450 without your extra points. And as I told you, I don't know whether I've already dropped it or no, I don't remember. So I will add the points for your quiz. Then I will, okay, then I will consider the quiz 1, 2, 3. So I drop the quiz 3. So it's going to be there, but it's not going to be counted in your, okay, in your total. So if you want to check any record, anything, just check it now. Then I call it test 1, test 2. So you may see the test 1 and test 2, then the grade is going to be different because I'm going to replace them by 2, your best one. Okay, so you see 2 grades, grade 1, test 2, and the 3 for your quizzes, quiz 1, quiz 2, and quiz 3. Then your assignment, you get 40 points for your assignment. So these are going to be your total percentage that you will see on the Canvas. Then there is your take-home one. So the take-home one, I told you that the case with the Canvas is it cannot add them together because we want to add them together, but we divide it by 4 and then 50. But the Canvas would divide it by, if it's going to be 10 points, they divide by 460. So I will add that together myself. So when I post your results, you will see one column for total percentage that you're going to have. Okay, that's it. And then I will add one more column. I call it course grade. Okay, so your course grade would be the way I'm going to do it is I will check this. You will see on the Canvas is going to be A, B, C, but the scaling that I use is for the A, I call it 90. So you may have 95%, but you will see your grade A. So it means you get an A, okay? Because that's easier for me. But if you have any question when I post your grade, if you have any question, you let me know. I'm happy to explain it to you. So as soon as I post your grade, then I send you, I give you a notice that your grade is available. You have 24 hours only. If you have any question, let me know. Otherwise, don't accept anything else about your grade after 24 hours because I will submit it. So if you have any question, you are welcome. Ask me, I explain it for you. If anything missing, I will be corrected for you, okay? So just as soon as you see it, so you get the total grade and the percentage and everything would be given to you. Okay, and all those take on one, you know that you get 2 points for each. So I have all the one over there. Okay, so this is let's see if we can say anything else. Number 11, we give you one problem on the average value. Okay, you did one on the test. It's the same thing here, but make sure you use that. You see that's the number 11. Make sure you study this one. Average value. You know that this is average value of the function. In this case, this is between 0 and 20. We did this one. 1 over 20 minus 0, integral from 0 to 20. And the function is 10 e to the 0.04x dx. Okay, just use the shortcut that I talked about it. You put out the 10, so that gives you 10 over 20. And you integrate this one, shortcut, e to the 0.04x divided by 0.04 to be evaluated from 0 to 20. Use your calculator, get the numbers, okay? It's very like the one that we did. And everything else is the same. Any question? Anyone want me to explain? Otherwise, number 8, 9, these are the one that we did for when we review for your quiz. And that's going to be the one. Okay. So have a good one and see you on Thursday. Don't be late. You need the full 2 hours to be able, to be able to do it. And we may give you a little bit more if you need it, but you should be able to do it. I give the same test at the university and they will be able to do it. Can I do number 12? What is number 12? Number 12, the area between 2 curves, yes. This is number 12. That is going to be, in number 12, the area between 2 curves. Okay, that's 12. And the curves are y equal to the 3 minus x squared and y equal to the x plus 1. You have to find the point of intersection first. So it's going to be 3 minus x squared equal to the x plus 1. We move everything to one side to solve for x. I move it to the other side. So it's going to be x squared plus x plus 1 minus 3. So it's going to be x squared plus x minus 2 equal to the 0. We factor it, it's going to be x minus 2 times x plus 1. So we have a 2 and a negative 1. So we have to integrate between negative 1 and 2. So we have to find out which function is going to be on the top so that we are not going to get negative answer. We pick a number in between, something like 0, that's optional. Okay, if you put the 0 here, so y equal to the 3 minus x squared, 3 minus 0, which is 3, y equal to the x plus 1, 0 plus 1, which is equal to 1. So this would be the one on the top, the bigger number, and this is the bottom one. Even if you miss it, you get the negative numbers, you switch it. Okay, so the area between two curves is going to be area from negative 1 to 2, y of the top minus y of the bottom, then the dx. So the negative 1 to 2, the function, y of the top is this one, 3 minus x squared minus x plus 1 all dx. So this is going to be negative 1 to 2, and that's a 3 minus x squared. Apply the negative sign, negative x minus 1 dx. Simplify it. So it's a negative 1 to 2, 3 minus, sorry, that give you 2. 2 minus x squared minus x and the dx. Now we have to integrate it, okay? Usual integration. The over 2 would be 2x minus x cubed over 3, and that give you minus x squared over 2 to be evaluated from negative 1 to 2. Carefully you substitute. It's going to be 2 times 2 minus 2 cubed over 3 minus 2 squared over 2 minus, open up the parentheses and apply the negative 1. 2 times the negative 1 minus negative 1 cubed over 3 minus negative 1 squared over 2. Okay, so the result, 2 times 2, 4, 2 cubed, 8, 8 third, 2 squared, 4, 4 divided by 2, that give you 2. Inside is a negative 2. Negative 1 cubed would be negative 1, but negative positive plus 1 third. Negative 1 squared is 1, so that gives me negative half. Now, 4 and the 2 would be 2, so it's going to be 2 minus 8 third. There is a negative sign here, negative, positive, positive 2 minus 1 third plus half. 2 and 2 would be 4. Okay, 2 and 2 would be 4. 8 third and the 1 third would be, didn't miss any sign, yes, a negative 1 cube. Okay, that's a negative 8 minus 1 would be negative 9. Negative 9 third would be negative 3. Okay, and the 1 half. So that give 1 plus 1 half, which is going to be 3 halves. So the area between two curves is going to be 3 halves. Okay, like on the quiz I told you. But your answer must be positive. If it's going to be negative, probably you didn't pick the top and the bottom. It's not a big deal. You rewrite to say, oh, A is positive because this is going to be just the area, and the area cannot be a negative number. That is number 12. Okay, yes, what's the question?
Professor, I have a question. When you say we have 24 hours after they're done to ask questions about grades, is that 24 hours after you post the latest quiz or after you let us know that you have put the final grade in?
No, I said when I graded your paper, I post your grade, and then you have 24 hours because there is a deadline for the college that I have to submit your grade. So this means as soon as I post it, then you will see it. So I wait for 24 hours. So means when I grade it, yeah, you should see it first. Not the quiz, the grade, the course grade. Okay, the course grade, not the quiz.
Okay, thank you.
Because the quiz would be, would be given to you. That's why. Okay, that's one. No, I can do any one more. 8L, last one. Which one do you want? I did all of them before. Which one do you want? I did this one before. It's easy problem. Let's move the x to the fifth up and just integrate it. What do you want? This is it, number 8. That is 8a. 8a, you want integral of 3x to the 4th minus 8 over x to the 5th minus 2e to the x. Okay, it's ordinary integral, no substitutions needed. But we have to move, we have to move x to the 5th up. So it's going to be 3x to the 4th minus 8x to the negative 5 minus 2e to the x dx. Okay, so this is it. It's going to be 3 times 1 up x to the 5th over 5 minus 8 1 up x to the negative 5 plus 1 would be negative 4 over negative 4. Okay, minus 2. E function is just the E function. Never changed. But the constancy. But you have to take care of the negative numbers and the negative power. So this is going to be 3/5. 3/5 x to the 5th. This is the way I write it down. You can write even 3x to the 5th over 5. We accept it. Now, you've got to be careful here. Negative would be positive. This sign of the fraction. Okay, this is going to be 2. You have to move this x to the negative 4 down. So it's going to be 2 over x to the 4th minus 2e to the x plus c, and you're done. Okay, so the point is about this one, you have to move it up to get these numbers. Okay, you must study. You're gonna start test 3. We give you this one on test 3, and then we repeat it on quiz 4. But in quiz 4, there was a number here. I think that was the one. Okay, any more of these numbers? So for integration, study the quiz. That was a very good quiz. Those 6 questions that we have. You see, I post the solution for you tonight. So if you have any difficulty, double check it. We have all sorts of integration that we need on that one. The leftover, if you like, is going to be integration by parts. So if you add integration by parts to your quiz, that make it into 8 questions. So you got to study that quiz if you haven't done it, or if you missed it. I know that some of you didn't try it. So you have to get back to it and do it yourself and compare your solution with mine. Make sure you are ready for it. So this would do quite a lot. This is very good, very dense quiz, and most of it did very well. So you should be able to get that one. It's going to be 80 points, so don't miss it. Any more of these questions? That's it. Have a good one. If you have any question, you can email me. I have one test tomorrow morning of the Palomar, but I'll be around. So email me, then I can get back to you before your test. Okay, any question you have. Study the final review. Test 3, quiz 4, and you should get 100% on the final. And we get people very excellent grade on the final. So why not? You should do the same thing. Okay, there's no reason that you cannot get 100% on this final, really, 100%. So that's gonna go. Could you show 10A? What's a 10A? 10A. 10a is just the shortcut that we talk about it. 10a, the final. Do you want a 10a? This is 10a. Integral of 0 to 1. 3e to the negative 0.04x dx. You see, it can be done by substitution method, but we give a shortcut for this one. You see, 3 is a number. You pull out the 3, 0 to 1, e to the negative 0.04x dx. Like on the quiz, you see, they're telling you the quiz. So 3 is just exponential function. Exponential function would be exponential function because it's a number only. You see, 0.04x divided by u prime, 0.04 to be evaluated from 0 to 1. So you pull these numbers, it's going to be 3 negative 0.04 e to the negative 0.04x. You put 2 zeros on the top, make it 300 over 4. It's going to be negative, okay, negative 300 over 4. And then you substitute. If you put x equal to 1, so that gives negative 0.04. Minus, if you put the 0, that gives e to the 0. That's it. Use your calculator. That gives 75 something to get the numbers. Okay, simplify this one. E to the 0 is 1. So it is going to be 150.75. 75 e to the negative 0.04. But you have to use your calculator. We don't accept this one as a final answer. You know, to get this one through. Okay, that is going to the one. No more. 9b, I did this one. What do you want with 9b? You move the bottom up. Okay, x cubed plus 3. What's difficulty for 9b? Did it say 9b? 9b. You see the 9b? Remember, it's a rational function, so you have to move it up. Rational with the power, that's going to be x cubed plus 3x plus 1 to the what? To the negative 3 dx. So substitution method, you take this one to be u, you have to end up with a u to the, okay, end up to the u to the negative 3, of course. So let's see what's the difficulty. This is going to be u equal to the x cubed plus 3x plus 1. Then the differential of the u is what? Is a 3x squared plus 3. Okay, the dx. It's just a technical point here. You go back and substitute. So if you substitute, this would end up with the x cubed, x squared plus 3. This would be u to the negative 3. Then your d, I'm sorry, I have to find the dx. Dx is du over 3x squared plus 3. I know what's your difficulty now. You see, if you substitute here, so that gives you a du over 3x squared plus 3. You see, to simplify it, oh, let's see. It's, I know what you mean. There should be a misprint somewhere because you see, that's going to be, usually we pull out this 3, and that should give us x squared plus 1. So you have to change this one. I know what you mean. You see, otherwise you can't do it. There's a misprint here. Probably, or maybe that is used to be 6. Okay, because otherwise you can't do it. Very good. Okay, I'm surprised this. Yeah. This is probably either one. Yeah, this is 1. You can change it to the 1. Then you should be able to do it. Then you simplify this too, and then you get the 1/3 out. Then you should be able, you know, to take care of it. Okay, so yes, you know, I was surprised. So you know that this is going to be what? This is going to be u to the, it's a 1/3 u to the negative 3 du. Then it's going to be 1/3 u to the negative 2 over negative 2 plus c, and then you simplify it. Okay, that's it. Good luck. Take care.